Yeah, I
Is
think
this
we
thing on?
are.
Is this
I
thing
think
on?
we are. I think we may have figured this whole thing out called the internet. So, welcome to the security table. My name's Chris Romeo, and joined by my good friends Izar Tarandosh and Matt Coles. And this is our first time trying to use the internet, so it's relatively new to us. After multi decades of being computer people, we're trying to
There's
use the
two.
internet. And so we've been doing this show, The Security Table, for, I don't know, a number of weeks at this point. I think we've got 10, 12, 13 episodes, something like that. We talk about things related to application security, product security. Sometimes we discuss civilly and nicely. Other times things get more heated when Matt tries to point out another standard that I should read and understand. I'm just kidding. It's all in good fun. We're here to have fun, but we want to talk about AppSec, ProdSec, general security things, just have a good time doing it around what we call the security table, which is a bit of a virtual table at this point. So let's talk about secure by design, though. Seems like it's getting a lot of attention. CISA came out with a document, secure by design, secure by default. Well, CISA and major governments from around the world came out with a document to try to put together and focus our thoughts on secure by design. And so let's talk about what it is first, in case people are out there going, I've heard of this thing, but it's a little bit of a nebulous concept. So Izar, give us some thoughts on
Oh no
what
no 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 no
is.
no! The good one with definitions here is Matt. Matt define and I refine.
Well,
Well, so yeah, so I guess I'll kick it off then. So secure by design, and of course we should just let users viewers know, of course, that it's secure by design, secure by default, right? So if you're searching for this document or set of documents, it's secure by design or secure by default. What we mean by secure by design is that the system has been implemented with secure design principles in mind, that it comes pre-hardened, that it comes pre-secured, and that the things that, rather than relying on customers to take something, install it, and configure it securely, that it comes out of the box that way. So secure by design, you build in the capabilities. Secure by default, it's configured correctly.
mhm. And Izar happens to be writing the great American novel off to
No,
the side.
I'm putting it. I'm putting it into the into LinkedIn, the URL for the doc, so that people know what
So
you're talking
people can
about.
follow along. That's
You need
good.
a less clicky keyboard there, buddy.
I will never have a less clicky keyboard.
All right, so Mr. Refinement here. The definition's been
So,
set. So how would you refine the secure by
yeah.
design by default?
So I think that the keyword here is aspirational, right? So we have been doing this thing for a long time, and we always keep telling people at some point people are going to learn and do the right thing and keep doing the right thing and just ingrain the right thing into what they do. And I think that the security by default and security by design is sort of taking that one step up and saying, now actively, we have to start looking from the beginning. Like, take the thing that we have always said about security is not something that you bolt at the end. It's something that you bake in. I love that you bolt, but you bake. Whatever. But
build in.
build in. But the thing is that now you want to start. You don't want to start from zero. You want to start from something that you finally, after much trial and error and catastrophes, you have gotten to that state where you know what things have to look like in order to be secure. And now you define that as your starting point, and you say this is what good looks like. And anybody wanting to build from here have to start at this level, have to start at this minimum amount of security. And I think that plays well with something that we keep going back to in the podcast, which is what's reasonable to do in terms of security. And so far from what I have seen, I haven't exactly seen anything like a hardening guide or configuration guide or 10 best practices for secure by design or whatnot. But the discussion is at a place that put things in a very reasonable starting point.
Yeah. So
It's interesting you bring up hardening guides, in fact, right? Because if you look through those documents, you'll find, with the notion that you start secure by design, that you build in security, you design it in, right? You don't just build it in, but you design it in, and then you deploy it securely. Then the theory goes that you can start looking at sort of de-hardening guides as opposed to hardening guides. Rather than have to build up from scratch, you can start allowing, if so desired.
Please,
Chris
please.
is shaking his head.
I remember when the three of us got a chance to provide some feedback on the CISA document through our threat modeling manifesto collective group. And that was one of the things that I wrote some strong feedback, and I feel pretty strongly about. Don't encourage anybody to create a de-hardening guide. If they want to figure out how to de-harden something that's been secured, let them figure it out on their own. Don't give them a guide that says, here's how you back out of all the security goodness that's been added to the product.
But that takes us to an interesting place. Why would somebody try to bring down the security posture of a system, especially when it's already been like blessed as secure? Right?
Number one reason I think that I think we've all heard over the courses of our careers: performance, right? Or accessibility.
So here's the interesting thing. I haven't heard performance as much in that context. If by accessibility you mean because the thing is so buttoned up, it's difficult to do A, B, C, D, right?
Yeah, or compatibility. We see this with old, we used to hear this with old web browsers, right? And secure, HTTPS services, right?
I hear that a lot with least privilege. Like, I don't know what I'm going to need this account to do tomorrow, so I'm going to give it a privileged role, and whatever it needs to do, it will be able to do.
Yep.
Right. So that there's that forward-looking idea of I have to be permissive because I don't know what I'm going to need tomorrow. Meanwhile, attackers are already having whatever they need today.
Yeah.
But that's something that I see a lot. The thing to me is that the more I think about this, and Matt and I have discussed this a number of times, it seems to me that as a security person, if I have to look over the shoulder of a developer at the time that they are developing, and I know that they start from a buttoned up state, and now they are asking me to open that thing up, it's a great opportunity for me to question that decision and help make it a better decision than the opposite situation when I'm sitting behind that developer and every keystroke I go on their shoulder and say, is this secure? Is this secure? Are you doing the right thing? Are you doing the thing that the training said that you should be doing?
Yeah, but de-hardening is a step removed from that. The concept of de-hardening is giving a guide to a customer so they can back out the security default changes you added to the product to somehow bring it into a less secure state. And what I'm saying is I can't think of a reason why somebody for good intentions and good purposes would want to back out the security settings, because you can't tell me it hasn't been tested, because we had to test it in this hardened state in our release cycle to prove it was ready to go out to the world. So I'm not a big fan of this idea of having a guide that tells people how to back out all the things I've spent 26 years saying, and you guys have done a similar thing. We've been saying these things over and over again for decades. Don't erase something good that's happening in the secure by design movement. That's all I'm saying.
Oh, but then it goes to what Matt said about compatibility, right? Because you wrote that hardening guide, and I want to believe that you tried a number of reasonable configurations. But there will always be that guy that says, I'm running, I don't know, I have a firewall from 1980 in front of the thing, and I need to bring it to SSL 1.
Yeah, but secure by design
SSL 2 won't go through.
Secure by design doesn't have a hardening guide, or secure by default. There is no hardening guide. There is nothing for the user to configure. It comes out of the box secure, and what we as the producers of the product say is a secure state. So the user, they can't say, well, compatibility, it doesn't work. Well, no, it worked because we had to test it in order to release it, to prove that it did, and we didn't lock it down so far that it couldn't do its job. It couldn't meet the functions that it had been called out to do. So that's
it's always those strange configurations go like Azar said, right? There's older systems, it may be older web browsers or older clients. This could be, let's just say for a moment that somebody adopts this late in their product lifecycle, in their like release 10 or 12 or 14 or whatever later, or 100 or whatever, and they still want to be able to support systems from 10, 20 years ago. And this actually was mentioned in the document as well about, well, this may break backward compatibility. And we have to be comfortable as system designers, making those hard decisions about whether or not to say, yeah, Mr. Customer, we're moving on. Think about that.
Yep.
Versus try to maximize compatibility across those.
Yeah, we are. We're comfortable with breaking backward compatibility. I speak for the industry. I speak for all of us.
No, you don't. Because you've seen enough times where product comes and says, we can't make those guys crazy with that amount of market share and just downgrade the security and it's going to be fine. It's never fine.
I mean, the risk tolerance in the world now is so much different than 10 years ago. But
on the other hand,
hear that as a good, I don't think that's happening as much as an argument now. No, we used to hear that all the time when I worked in a big product company, but that was 10 years ago, 15 years ago. The internet, the world, the expectations for security have changed so much though in that time.
But it's not only the expectations. I think that we are perhaps fortunate to say that we have such a problem as alert fatigue. And we get too many alerts because now we have too many eyes looking at what's going on, right? So once upon a time, we would say, I can't downgrade security because if something happens, I don't have something that will tell me that something happened. Today, we have a lot of solutions and we have a lot of ways to getting the pulse of what's going on in our systems. Not that that's a justification. Far away from it. I sit together with Chris on the bus of, don't you touch that thing. Nobody here presses the big red button. But I just think that being pragmatic, if it happens, we do have enough logs and metrics and traces, the whole observability suite to come and say, something unplanned is happening here. And perhaps we have to hit the big red button again.
Yeah. Okay, so there's more to secure by design than de-hardening guides. That was just Matt set me off on a tangent there. It was a little bit of a memory of going through the document and reviewing it. But when I think about what they think of as with secure by design and what the document calls for, I mean, there's a number of other things. But for me, I always want to bring it back to that magic word, design. Secure by design. What's that thing that all three of us love that somehow plays into design and makes it, there's a book.
Ice cream.
We do all love ice cream. I mean, this stuff's not to. But, Izar and Matt wrote a book about it. They love threat modeling so much. And so when I think secure by design, though, I know threat modeling is a piece of secure by design. I don't know. What do you guys think? Like how does threat modeling fit into secure by design? Is it secure by design? Is it a layer below secure by design? Is it a piece? How do you see it fit in?
So I think that threat modeling is a way to inform and in part to validate the design and its security, right? So with threat modeling, we can look at a design, and we generally say that the best time to do threat modeling is when the design is formed but not well baked, meaning not fixed. You have time to change it. And so you have an opportunity to use threat modeling to influence the properties that you need and influence the design to make it secure, and to make those trade-off decisions about what you can and can't enable, or can and can't support. And later, and as we'll remind folks here, we have the threat modeling manifesto, when you have the 4-question framework that we leverage, right? So we're going to start with, what are we working on? What can go wrong? What are we going to do about it? That gives us the design part and the secure design part. And then, did we do a good enough job? Later, we can use threat modeling to validate, did we actually implement the things that we need? And did we effectively address the secure by design part? That will also feed into the secure by default piece, because we can understand sort of what's a built-in characteristic versus what's a configuration layer that gets added on, and it's not the same as bolted on. It's configured later to add security capabilities, or to enforce security capabilities. So I think that's where threat modeling really fits in here, is informing and then validating that security design practice.
So that's how the process of threat modeling fits into the secure by design thing, let's say. To me, it's also about how the secure by design thing fits into threat model. And what I want to say by that is that many times in the past, we are asked again and again, how do you threat model in an agile situation? How do you threat model in the cloud? How do you threat model SaaS? How do you threat model this, that, and the other one? And another thing that we put in the manifesto is that threat modeling is evolutionary, meaning it gets better every time. Now, if we look at all the situations of development, plus the thing that we get better all the time, one thing that becomes very clear to me is that we work in deltas. We don't always go back to zero to threat model, right? We work on the changes on the system. And it's funny because the thing that immediately jumps to my mind is that we as threat modelers, when we do threat modeling, the things that excite us are those things that you guys are trying to do different. This is a new thing. This is a shiny new thing that nobody has done before. We get bored by, again, looking at the VPC and the permissions and who's talking to whom and where is this process running and authenticating. That's the stuff that you need to get off the ground. And to me, security by design is going to bring the thing in terms of they're going to cover the whole boring stuff and give us time and liberty to play in that sandbox of the new shiny thing. We're going to be able now finally to look in depth at things like business logic and innovation and things combined today that weren't combined yesterday, right? And start focusing on that new stuff and that new attack surface, and let the stuff that has already been explored, already been turned into standards. This is how we run a secure database here. This is how we run a secure server of whatever here.
Yeah.
And now just tell me what you're doing different.
Yeah, that's, I mean, looking at the diffs is how you do code review in a pull request moment, or using a pull request. You don't go review 5,000 lines of code when there were 3 lines changed. You focus on the diff. You focus on the diff and then the context around it enough to understand, did what they change fix the problem or make the thing go away? And so, it's like a differential almost approach to looking at what's changed and applying that in the model.
And you heard it first here on the security table, live on LinkedIn. I'm calling this exceptional threat modeling.
I tried to rebrand it for you.
Modeling.
Plug.
The exceptions.
But I tried to rebrand it for you right on the fly. You didn't catch it with differential threat modeling. I went for it. I gave you
No. I have a history with anything that is differential, integral. I have a bad history with that stuff.
Okay. I don't actually even know what it means. So I mean, it sounded
I try
good.
to keep away from those things as much as I can.
Okay.
But you know what? Exceptional I can play with.
That makes, well, it's a first. There could be a new book in the future hanging on the wall behind these guys.
It's going to be on Threat Modeling Connect in about 10 minutes.
Ah, perfect. We'll try to pay attention for the rest of the time we're talking. Please don't drift off and start typing his blog post here, trying to get credit. Because this is live. Someone else could be typing that blog post right now with concepts.
It won't be the first time.
So secure by design is more than threat modeling. And but it is design,
it goes hand in hand with
focused. It does go hand in hand. But I'm looking at what the CISA document talks about. First of all, memory safe programming languages. So you can argue that is a design activity because you had to design what language you were going to use to build something. Now, does that mean,
or because the language that you are using changes the design?
Right.
Yeah,
it influences the design.
Yeah, definitely. Like, and when you think about the proliferation of new languages like Rust and Go, which are replacing what we used to use C and C++ for, and Rust and Go have enhanced security mechanisms in place to prevent problems that were easy to stumble into in C. memory, security, doing proper bounds checking and memory management in the language itself. That's a step forward. But that was a design decision. And we realize if you have an existing system, existing product, you can't just go say, well, from this point forward, we're going to use Rust. Now, we wrote the whole thing in C, but from this point forward, we're using Rust. So if you're going to make a change, you make it in Rust. Like a language choice is more of something you can do upfront with something new you're building. It's a little harder to change both engines on the airplane at 30,000 feet, which is what you're effectively doing if you're changing your language in the middle of a program or product.
Yeah, that's true. I guess that's where a proper modular design and having the ability to create wrappers or front ends or other things that take that newer construct and put it in front so that it provides a level of defense to your legacy modules until you have time to replace them. Not suggesting that you should leave old C code around unless you make that decision to do so, but you could take Rust and build something around it that works and that gives you security capability. Defend the core, right? And so it's an evolution. And I think we see with this memory safe language decision especially, right, that if you're not spending time, like Azar was just talking about, right, with exceptional things, if you're not spending time on solving the problems of how do I make interfaces secure, because the memory safety can address that for me, or more important, or also that language can also enforce certain structures or constructs, programming constructs. So I don't have, as a developer, I don't have to worry about those sort of things. I can spend time making interesting business logic decisions and less so worrying about making sure my APIs only take the proper data and only output the proper outputs. Right, the language takes care of that, or at least lets me know what I need to take care of. Right, and so it frees up the developer from that responsibility. In part, they still have to make a conscious design choice, right, to use the language and how they bolt it on, how they connect it together with the other pieces, and how they might replace portions of it. But it gives them some flexibility, some capability there, and so that's a good thing in general.
Yeah, but Matt, keep me honest here, because you're much more experienced in this than I am. With the proliferation of IoT and small devices and things like that out there, right?
Mm-hmm.
So one of the design choices here is actually what Chris said, go to a memory-safe language. But because of limitations in these devices, many times because of memory, because of CPU, whatever, you don't have that liberty. You can't just go and start writing on a different... There's a bunch of devices out there that you can't write in Java because there's no space for the runtime.
But yeah. So right, you have space constraints, or you may have compile targets and other things that might be a problem. Right. Yeah, exactly.
But then you can look at C again and say, okay, I have to write in C because that's what runs in this device, but I have the design choice of using libmalloc that does do all the protection of memory spaces for me. Yeah. Or so you can go further and you can say, I can work on a processor where the hardware already makes that boundary checking in a more secure way. I don't even know if that thing exists. I think that I read somewhere that it does. But you start having options at different levels for the same design that at the end impact everything.
Yeah, I think that the memory safe language discussion was really, and this is, I guess, this is research being done out of like MIT and NSA and other folks, right, that have a lot of brain power put into this. But thinking about what percentage of the development population are writing for specialized targets like embedded IoT devices versus those who are writing web or cloud-based code. Right. So there you're going to get more general purpose systems, more general purpose, commodity processors and whatnot, and therefore switching to memory safe languages frees up a lot of developers' time takes away the choice of building insecure code. And we're just talking memory safety, so we're only really talking about buffer overflows here, right? And off by one errors and things like that. except for the newer languages that have also better interfaces and less undefined behavior and whatnot. So it's a little bit better in that regard, that to not introduce new weaknesses. But when you're talking about going to embedded devices, so I'm a big proponent that C is very hard to get correct. You need proper diligence to get it correct and make it secure, and that's not all right. You're giving that face. Do you disagree that C is not possible to make secure? Because I think it is possible if somebody takes the time to do the effort.
Nice recovery.
I was always on that track.
You got to wrap it. You got to have to wrap it in a lot of different layers of bubble wrap to give me a safe C world where I don't have to worry about buffer overflows and integer overflows and all of these things in the code that's being cranked out. And like, that's, I think, is the balance. That's the balance, though, right? With these memory safe languages. Like, that's why that you got to find a way to build new IoT devices not using C. Like, C is a great language. We can't completely poo-poo it because C is the foundation of everything that we have now. Unix,
assemblers,
but Unix and C were kind of side by side with each other, like through that's the history of computing for all the young whippersnappers out there in the internet land, right? But that's the truth. Like, that's where it came from. But it's secure by design is about raising the bar, constantly raising the bar, and we have to do that
because of all the lessons that we learned in the past.
Yeah, because we've been there.
Right. And so I mean, it's very encouraging now that Rust is part of, if I understand correctly, if I remember correctly, that Rust is now part of the Linux kernel.
Yes.
So it can be done. You can build, tight, privileged code that's designed to run against multiple targets from this newer language, that it isn't bloatware, right? That it does do its thing in a concise way. And that's important, right? And so if we're looking at IoT devices that have memory constraints, as long as we're compiling to that, as long as we can compile to that target, right? So if we're looking at an ARM chip, right, that has limited capabilities in terms of memory footprint and CPU power, as long as we can compile code, to that target, it doesn't matter if it's, so in terms of just having it be possible, whether it's in C or Rust, as long as it compiles to machine code, it can go on that device. Then the choice becomes, where do we put our engineering effort? Do we put our engineering effort into taking this 40 or 50-year-old language that is hard to get correct, or do we move to something that's memory safe so that we can free up our developers to work on hard problems and not be shot by this obvious problem, right?
And folks can go back and listen. We've been talking about paved roads and guardrails. It's come up a number of different times in different episodes, and that's what we're talking about. A memory safe language is a paved road that you're providing for the developers so that they don't have to worry about memory safety, because the language is going to enforce it. And that's, as we've all talked about, reasonable security, reasonable AppSec. Paved roads and guardrails are reasonable. They help us build a reasonable system that still lets developers be creative and freestyle and do cool things.
Yeah, and another thing that I think that we have to jump to here is that we have been looking at secure by design here in this conversation. We have been looking at secure by design and secure by default as, okay, we built a secure base. Now you guys go and show us how you're going to screw it up. And now I'm thinking of, okay, the base is there, fine, secure by design, secure by default. Now let's see about this screwed up part. Sorry, my Google in the other room heard the okay and went crazy. But the point I'm trying to make, I think, is that there is a change in mindset when you start talking secure by design, right? That is less, and Adam, forgive me here for the heresy, but I think that it breaks a bit the model of the 4 questions. In the way that today the 4 questions ask, what are we building, what could go wrong? When you start talking about secure by design, is, here's what I'm building, and here's why nothing is going to go wrong. Because you are already incorporating in the design of the thing that you are designing security. You're shortening even that jump from, I said in the beginning, it might sound as heresy, but I think you to think about
base.
that.
Yeah, it's not heresy, it's just wrong.
I think you're
I'm open to being
delusional
wrong.
there.
I mean,
I think there's a bit of a delusion going on there. Is there? No offense.
Too much
we're all friends here. We're all friends here.
I mean,
around the table, right?
It's business logic.
Too much monster.
It's business logic. Like, developers are building new features. Yes, they have a secure foundation, but business logic can still go wrong. They can still make mistakes.
It can definitely, totally.
Still
I'm
need
not saying that
model.
it's not going to happen. I'm not going to say that it's not going to happen. What I'm saying is that when you say secure by design, okay, you are taking that security is bolted on that we used to put way there at the right of the process, right? And that was brought left by things like threat modeling.
Mm-hmm.
And now it's not even left. Now it's part of that design thing. It's like I'm designing already with security in mind. Mm-hmm. And you know what? Delusional, I'm willing to take it. Overly optimistic, I think it's more appropriate.
Overly optimistic. I like that better than delusional. Yeah, I mean,
but I'm willing to take the delusional.
It's not going to solve. It's not going to solve all like this. Secure by design doesn't solve all of our problems. It doesn't result in. I mean, we need to get a sponsorship.
Too much
deal.
Monster.
We need a sponsorship.
Too much
deal.
Monster.
Monster energy drinks. If you're out there, Monster, there's a sponsorship for you here. Just send Izar a case.
We're taking sponsorships here.
So we'll take them from anywhere. But no, I mean, I think it's paved roads and guardrails. They provide the right pieces, the right things, but secure by design isn't going to solve all of our problems directly.
No, nothing's going to solve all the problems because exactly what you said. At the end of the day, we are developers developing stuff. We will, and
we want that. We want that innovation. We don't want to be. We don't want to live in the worst possible thing is we live in a no code, low code world.
Exactly.
Where all you're doing is plugging Lego pieces together, and then you're saying this is the best application. Well, no, it's not. It's no more innovative than the one next to it because it was constrained by the boxes that you only had the component pieces. You didn't have the ability to think up and dream up something new. And so, I mean, low code, no code has its place, but let's not let that become how we build software everywhere.
So, let me not go there.
Yeah, this is a live stream, so don't go there.
No, I already said too much today.
Let me bounce one more in here, and then we'll wrap up for this week's episode. They put parameterized queries. Use parameterized queries rather than including user input in queries to avoid SQL injection. We've all been saying that for 20 years now. But is that a design? That's why I'm looking at that. I'm going, is that secure by design? Like, do I even have to? There's no choice there. Is the fact that there's no choice, is that a secure by design tactic to use parameterized
only if
queries?
Doing the right thing is a tactic, because that's the right thing to do.
Yeah.
For more than security reasons, it's just the right hygiene. It's just the right way of structuring your queries.
Yeah, and to put it in perspective, the one right before it, web template frameworks, use frameworks with automatic user input escaping and to avoid web attacks like cross-site scripting. That's a design choice. Now, the frameworks are getting better every day. Frameworks are caring about security. You don't have the same challenges, but there's still a design choice. I could make a bad choice. I could choose a framework that doesn't care about I won't say doesn't care about security, but hasn't invested in security at the same level as some other framework. I have a design choice. What I'm saying is, do I really have a design choice with parameterized queries?
Yes, because one of the examples that I have seen in the past, whenever I ask a developer to use an ORM, and I have seen this repeatedly, developers are extremely smart people. The problem is that sometimes they are smarter than they need to be. So when they find out that even using an ORM, you can write your query as it is, full string, pass it to the ORM, and the ORM will usually have an eval call or whatever that will use that query. Yeah. That the language that you are using possibly helps you do in a dynamic way. So you're taking the ORM, you're going through it and breaking.
In their defense, There are situations where the ORM is not performant enough. For example, in reporting and dashboarding and whatnot. I've seen so many times where I preach the same thing. Everyone should use the ORM. But then there's somebody shows me an example and says, well, the ORM, through the ORM to generate this dashboard in real time takes 4.5 minutes. And if we write a custom SQL query, it takes 100 microseconds or milliseconds, whatever, something like that. Like I can't say you have to use the ORM in that case because I can't take 4.5 minutes to render a dashboard. They won't even be a customer. They'll have already left.
Right. But I can't say that I've seen that, but just putting myself in the seat of a developer, and I haven't been one in a long time, in that particular case, the query that you are going to put together to send to the engine to get your dashboard back is probably something highly structured. You have a start date, you have an end date, you have a bunch of things that you want to see in the dashboard. It's not like, okay, I can't use the ORM. Great, the difference in that, I'm going to validate the input, right? It's not like one solution fits all, and that's all. We have those things in the way.
Yeah. But
yeah, no, I totally see what you mean. As I said, I've seen developers tell me I bypassed the ORM because I needed to, and there are valid cases.
So then maybe I'm starting to convince myself that parameterized queries is a design decision. And I would also say proper use of direct queries, because we know there's a use case for it. I can't just say you have to use ORM and you can't ever use a raw query. What I can say is you cannot use a raw query that takes input from the outside world. So if you need to do dashboarding, you need to use the ORM for any processing of data that's coming from the user. And then your query can just be a string that doesn't, you figured out the query because you needed an outer join, an inner join, and something else all together in one to make it work that the ORM couldn't replicate. Then I can see that as a scenario.
But here's the beauty of the thing. Because Secure by Design says that using ORM is the right design decision, okay? If I am a security person in a company that has 300 different things that I have to be responsible for, 299 of them will use the ORM and be just happy with it. There will be one that has an issue, and now I can ask them, instead of, okay, let's sit down and threat model 300 things, I can ask everybody, are you using an ORM? Are you? 299 will say, yes, I am. Fine, go away. You've been threat modeled. You've been blessed. But that guy that has the thing that is exceptional, that's the one that I'm going. That's the one that I'm going to sit down with and have a deep conversation to see what else can we do to help you run this thing securely.
Yeah.
Right. Mm-hmm. So you just validated exceptional threat modeling. Thank you.
That was my intention. This whole conversation, I was like, how am I going to work it in? How am I going to get EZAR's exceptional threat modeling to be the answer to something I say? I tried.
The only thing that can complement exceptional threat modeling is continuous threat modeling. So you have to continuously look for exceptions.
Wait. Exceptions with an A or an E? Exceptions? I'm kidding. Different kind of exception.
I think it's the end of the day for some people.
Yeah, all right. Well, it's not my mother tongue, so don't play with that because I'm gonna go look for it.
All right. Well, let's wrap up this conversation on the security table. It was great to be live here on LinkedIn, and we'll do that some more in the future. And just talking about Secure by Design, and I think we had we drew out some good points about how Secure by Design comes together, what it is. We're going to hear this a lot more. This is a thing of the future and the present. It's going to become a lot more prevalent in different scenarios and different conversations. So keep tuning into the Security Table. You can find us on wherever you get podcasts from, or YouTube if you want to watch episodes, or LinkedIn, or maybe we'll show up on some other new social media platform no one's even thought of yet. Thanks for joining us.
Everywhere.